Good afternoon, everyone, and welcome to School Physics Educators Forum. My name is Anand. I was a physics teacher in schools in Chennai for about 15 years till last July. Now I'm a faculty at the Teacher Education Department in Azim Premji University in Bangalore. We will not stand on any formality today, as most of it was done in the previous session. So we'll go straight into the topic. Thanks to all of you who joined. I see some of them who joined will definitely be helped by this session, and so I mean, it's Sunday and you all came in, so that's really great. And special thanks to Azim Premji University for providing us with this Zoom license to conduct this session. Now, please feel free to stop me at any time. Keep your video on. You can bring a cup of coffee, you can sip it, relax. There's no formalities here. So feel free and stop me at any time you want. I do have a few things to say about practicals and all that, but I think I would want to wait. I will first take your questions. And then if I'm able to answer, or if I'm able to say the things that I want to say through your questions, I think that would be much better than me having a monologue here. Please go ahead. If you have questions, I'll be more than happy to answer.
So I have a small question, sir. See, radius of curvature is equal to 2f that we all know. So focal length should come as r by 2. So never do we get exactly r by 2. May I know the reason, please?
No, are you referring to any specific experiment?
Yeah, for the focal length, to find the focal length of convex lens, whenever we do, we actually don't get the exact f r by 2 value. That's my question.
Yeah, I want to just clarify. Why are you referring to it as r by 2?
Okay, radius of curvature, because
yeah, I know, I understand the formula bit. I understand.
Yeah.
But do you measure the radius of curvature first before you find the focal length?
Basically, no. Yeah, we don't know.
No, you don't do that, right? How do you measure the focal length? Say you get a batch of lenses. How do you check the lenses?
So first we take that rough focal length using distant object method. All right.
No, I'm not talking about the exam or the student doing. I'm saying, how do you check this? How do the people in the lab check and see if they are exactly that value? So
what we do is, according to the procedure, the lab assistants and the teachers, they first conduct the experiment as such. That's what I'm just saying, that distant object method, we find the focal length, and then we repeat the whole procedure that the student has to do in the lab. And whichever method it is if it is UV method or 1 by U, 1 by V method, but still, suppose if I say focal length is 10 centimeter, it is somewhere falls between 9 and 11.5. So that was my question. So why doesn't it actually come to a 10? And how will we give marks for that?
Okay, so first things first, I mean, since you asked, I'll just tell you how I went about this. So when I get a batch of lenses, the first thing that I do is I don't mix it with the ones that I already have, because they have all been carefully sorted out and kept separately. Now, making lenses very accurately, and especially getting stuff from India, unless you go through a exceptionally reputed company, which are very, very few. I know one or two of them. Yeah, but making lenses to get exact value is a difficult task. That is, if somebody sends you, say, 20 lenses of 10 centimeter, the chances that my own experience has been about 5 of them will be exactly 10.0, right? The rest will vary this way, that way, and this is from a good dealer. This is from a good dealer, right? Now, what I do is, this I have mentioned in the last year's session also. What I do is I first set up an apparatus, right? This is for all those who want to take part in, actually, when you get the equipments, you want to make sure, see, it's one thing, it's students that go through a lot of stress in doing the exam. But I think it's even more stressful if their equipments are not accurate, right? So I think from our side as teachers, we should make sure that that we do our level best to get the equipments well calibrated and that everybody gets precise instruments, right? So this I will focus on today. I learned this from my teacher where I studied, because when I took up this job in 2009, I had 5 students, 10 students, at the most 15 students, and I had to arrange half of that because there are 2 batches of basically, I mean, they're split into 2, and then in the middle of the exam, they swap, and then, so I just have to arrange half plus 1. So if there are 15 students, I arrange about 8 or 10 lenses I will arrange. And these 10 I will painstakingly do. But see, my teacher from school, Mr. Narayan Gutti, he used to check 100 lenses and he used to do it alone. Right? I know this because I called him once I joined, a lot of it I learned from him. So that's an anecdote, that aside. So what you do is you set up an apparatus, right, to check the lenses. So what you do is, what I do, I'll tell you, I'll keep an optic bench, I'll keep a lens holder, I'll keep a screen, right? And I will make sure I focus on an object very, very far away. How far away? As far away as possible, right? Ideally, if you can get about 20, 30 meters away, if you can get a large chart paper, yellow color on a bright day, and if you don't have yellow color, something bright or white, and if there is no light when you're doing this, maybe if you can arrange for some light to shine on it somehow, but keep it very far away. But it's very important that it is aligned with the what do you say? It is important that it is aligned with the principal axis, right? You keep the screen, you keep the lens holder, and then bring your batch, the new batch. One, you put the first lens in, and then you find the perfect position for you and take the reading. And even in doing this, there are many small minute details that you can look into. I'm answering this question because you asked why it is not being accurate. Yeah, that's why I'm answering this question. Okay. So when you're checking, see, the distance that you calculate on the scale must be from the middle of the lens, center of the lens, to the surface of the screen. Now, you see, the screen itself will have a certain thickness when you keep it. And like you keep the lens holder and you keep the lens here, you align the center of that lens holder or that center of the lens to the scale, right? And there is a natural tendency that you do the same with your screen as well, that the center of the screen is taken. That would be wrong. You make sure that you keep the surface of the screen aligned with the 0. This is very, very important, right? Keep the surface of the screen aligned with the 0, because in taking the center itself, you lose 1 or 2 millimeters very easily, right? And then you keep one lens, you keep it at, say, if it is 10 centimeter lens, you keep it this at 0 and this is 10. And then you keep the lens there and you check that. And then what I do is I keep a sheet of paper on the side, and then on the sheet of paper, I write 10.0, 10.1, 10.3. And if this lens that I did, then I get a precise 10.0, I take this lens and put it on top of that where I wrote 10.0. Then I take the next lens. I'll check that is 10.2. So I'll keep this lens on top of 10.2 where I wrote on that sheet of paper. Then the next one I take, it's another 10.2. So I'll keep it piled up on top of that one. So once you repeat this for the entire new batch, you will see there is a whole bunch of 10.0s, 10.1s, 10.2s, and 9.9s, or however you get it. Now, when you do this and say, I have 15 students, how will I choose lenses from this? I will take all the 10.0s, say, supposing I have, for easiness sake, let me say 20 students I have. And 20 lenses I need to arrange. 20 lenses, if you need to arrange, that means you will have about 30 students. Yeah, half the number is there because you swap in between. Unless your lab is very big and everybody gets their own equipment, then it's a different story altogether, which is a good thing in my opinion. So you take the lens, I take all the 10.0s and say I need 20 totally. I take all the 10.0s and say I have 8 10.0s. Then I'll take all the 10.1s and all the 9.9s. This is what I do. And if that kind of makes up my 20, then good, right? Now, if the allowed limit, the error allowed by in measurements, when you make measurements, that there is no measurement without error. The error that is allowed is plus or minus 0.5. So you're allowed to use lenses which has a value between 9.5 and 10.5. My own personal suggestion is that you bring that as close as possible to 9.8 to about 10.2 if possible. That would be really great. Now, you asked the question why students are not getting very accurate values. If I may ask, they are not getting accurate values for any one particular experiment, for all experiments, or what about the distant object method? At least for that, do they get accurate values?
Yeah, distant object method, they are getting the accurate measurement actually. It's only on the optic bench when they do, as you rightly said, that taking the distance, maybe they're missing that 1 or 2 millimeters.
Yeah. So for that, there are many reasons that I can think of. One would be you need to check all your instruments to see that. When you get a lens stand, when you have a lens stand like this, right? You need to make sure that when you keep the lens on top of it, that they are very well aligned. Now, you told me that at your place you have all inbuilt optic benches, is it not?
Yes, sir. Yes.
Yeah. So you want to check those once more. Take another separate scale and see if the scales. Why I'm saying is this is not a joke, huh? Because when I joined in 2010, this guy whom I was who was procuring stuff to me, he gave me a meter scale that had 11 divisions in a centimeter. Right? It was atrocious. I mean, who checks when you get a scale? Nobody checks if there are 11 readings. You would just assume that these are the things that people get it right, but it had 11 divisions. So this is an extreme example. Of course, you want to go back and check these instruments to see if these are all accurate, right? And if they are doing the 10.0, if they are getting, you're saying by distant object method, they are getting it right. Yeah. One is, please check that for distant object method, make sure that the object is very far away. That's very important. Right? If the object is slightly closer and then they get 10.0, then obviously that means that the lens focal length is not very correct, very accurate, right? So check the lenses you have to sit and do it with a lot of patience. The best part is you do it once. What I do is, I do it just once and then I put it in a box and I use it only for the exam. I don't use it after that. For the regular practicals and all that, only when under my supervision, I take these lenses out and I make sure that it goes back into the same box. And what you need 20 centimeter lenses, 15 and 10 centimeters. That's it. You don't need anything else. So if you can get this done one time around, that would be good. Coming back, the other reasons why it may not be working is, of course, the obvious thing is that the children are not doing the experiment properly in the sense that they don't have a sense of no parallax. Right? That sense of no parallax takes some time and to get. And also there are issues about the parallax when you look through the lens and you see some children only scan, if you should really, I urge you to watch the last year's second discussion last year, where I discussed this in detail, very minute adjustments that students will have to look for or will have to make in order to get this very accurately. Yeah. So I really urge you to just watch that, because I do it with diagrams and this and that and all that, which I don't have prepared now. So I think that should give you a sense of some things that you can look into. Yeah. If your equipments are all right, and if that you can check, then it's just the way the students do the experiment.
Sorry to interrupt, sir. Where would I get the access to your previous year's that video?
Yeah. So how did you join? You must have got this one, no? You must have got a WhatsApp message.
Correct. Yes, sir.
Yeah. In that, the link is there. Yeah.
Okay.
So otherwise, let me just, you just go to, let me just type that down 1 second. This is the YouTube channel. So you go to this channel and look in the playlist. There's one called Physics Discussions. In that you look for last year's discussion. We had two. The first one was practicals in general, basics it's called, and number 2 is called advanced. So in advanced, I think that first part would be what you're looking for. I delve into in great detail about all these things.
Thank you, sir. Thank you so much.
So, I mean, generally speaking, since you asked the question, one is check the equipments. And you are saying that they are getting it right when they're doing distant object method, which would mean that it's working well, right? Now there you want to ask yourself, the only place that you can get that wrong is once you're not focusing on the surface, you're focusing on the middle of the screen, which is a mistake, right? Then the other thing is that the distant object is not very distant. If these two are fixed and then they get accurate value, that means the lens is good. Then during the regular UV or displacement, whatever you're doing, you don't get the answer. That is definitely because they're not doing the experiment correct. Yeah. I want to ask you, when you do it, do you get it correct?
Yeah, that was my next worry, because when we are doing, the teachers and the lab assistants, we are getting the correct accurate value. So maybe the personal error that the student is making makes a difference.
So this now you need to ask yourself the question: how do you communicate what you do correct? You're doing something right. That's why you're getting the answers correct. How do you communicate this with the children?
Before the practical classes, we have sessions. We have 3 dummy practicals, we would say. So before those sessions, we give them a class of what all the possible errors that the children may commit. So in that, we actually, what you right now said, we actually stress on that point, that how to take the readings right from the center of that stand to the surface of the lens. So that is from our side. Okay. Maybe due to the stress, the child overlooks of this fact and commits that mistake.
Yeah. So in this, one of the things I can focus on more is, number one, when you communicate this to the students, if you give them a set of, these are all the mistakes that you can make, they are not going to be very sensitive. I mean, they're not going to be very, careful. They will make errors. The best thing is to let them make the errors. What I used to do is I used to get 3 mock exams, no? And in the first mock exam, I will keep it simple, but I will not give them any marks because it's an internal thing. It doesn't really matter. So I cut marks for not writing significant figures, left, right, and center, so that for the next exam, they will do it better. And for the third one, they will be really well prepared so that the final one. So this is one. The other thing, of course, is even during your regular sessions that you let them make the errors, right? If you're in a hurry to say, finish the experiment and make sure because, that is a very clerical thing in the sense we need to make sure that everybody has had the chance to do the experiment. I think maybe you need to take a step back from, I'm not saying that you do this, but I'm saying if people do that, I think you need to take a step back. If there are 10 experiments, you should arrange for 15 sessions, a couple of, just children kind of getting used to how, I know this because I've done this. My students I had very small numbers. So maybe that was why. You have very large numbers. So my students all did their practicals fairly well. Right? I did not have a problem. They made mistakes because of silly errors or some dumb thing that they did during the exam or something like that. Not because they were unprepared. I made sure everybody knew how to find no parallax and null deflection point and so on. So this is something that you can think of. But do get in touch with me if you have any very specific thing. Are you part of the SPEF group, the physics group?
Yes, sir. Yes, I am there.
So I am there in the group. You can just ping me and feel free to call. A lot of teachers do call. Right? Feel free to call if you have any specific doubts, because I think I think in these first 4 or 5 years, I spent a lot of time collecting data about lenses, about readings and all that from the students. I used to enter it all into Excel and then go through and find out, because some great insights you get through this. And when it comes to the practical, the electricity experiments, I'll tell you some things that are quite counterintuitive. In generally speaking, I will tell you that as we go on. Okay.
Thank you so much.
I hope I answered your question in some way, but I really urge you to watch that video. By the way, for all those who are here, these videos they're all tagged at the bottom. So if you just hover your cursor over the navigation bar, you will see the chapters where I've clearly mentioned what is being spoken at that time. Right? So it's easy for you to navigate through because it's a long video, no? So just or look in the description. I've clearly mentioned. So that should help you to pinpoint exactly where to look. Right? Okay. Anybody else? You have any other questions? Salman, go ahead.
Yeah. Yes. I just want to ask regarding this experiment, that is the third one, finding out the focal length of a given convex lens with the help of an auxiliary convex lens.
Yeah.
I right now I did this last term like somewhere around September. I didn't remember actually the procedure how we did. Okay. But actually I have an issue. I don't know. I'm trying to follow the procedure which you have given to me. Remember when you are in good at school, you shared some copies with me. I'm trying to follow that.
Yeah.
But I don't know. I end up with not getting the result. Or not able to figure out what exactly is going on with that.
So when you say you don't get the results, how off is your answer? If your answer should be 20, what?
Yeah, somewhere around 20, something like that. Are we actually finding we're not keeping close in contact, right? We're keeping away.
Yeah.
But if they are with some, let's say that if they are away, then there is a different formula to find out the effective focal length, right?
So, one of the things that you might make a mistake in is choosing, first of all, you have lens A and B. You need to ask yourself, which lens are you finding the focal length?
Exactly. That was a confusion because nowhere it was mentioned there.
Yeah.
Whose focal length we are going to find.
So if you have taken the latest version of my write-up, I have corrected that. If you read, it clearly mentions that you are going to find the focal length A or B. It's written clearly. And then you need to ask yourself, if you're going to find the focal length of A, do you put A first or B first? So the procedure does not explicitly indicate this, because I don't want the students, I want the students just to follow the instructions.
Yeah.
So this is not, maybe I should write a separate write-up to the teachers explaining this.
Those who are using it.
Yeah. And if you use the theory of combining lenses, I think that should suffice. Okay, yeah. Then just try that.
Then shall I try based on the council thing which they have given recently, which I shared with you earlier? Shall I follow that?
So this is also one of the reasons why I didn't want to put this up on in YouTube, because you see, I saw the council's document. Yeah. So I know how these documents are made. I don't understand why they have included so many new experiments.
Exactly. And in the syllabus, I was just checking the syllabus copy. There are just 11, but they did in very different way.
So you look at it this way. See, we have a very peculiar situation now that the teachers who go to another school have to prepare the question paper.
True.
Yeah. Now imagine, I can tell you for certainty that the last 4 years that the council prepared the question paper, that is 2020, 19, 18, 17. In these 4 years, 3 years there were mistakes in the question paper. 1 year was a very gross error, right? Where they asked you to measure 4 volt with a 3 voltmeter, which is, in my opinion, I mean, it's crazy. You can't do things like that. Yeah. That was 2017 question paper. If you have that, if you go through, you will see that you are asked to use a 0 to 3 volt voltmeter. Yeah. But you are asked to measure 4 volt, which is really crazy. And I wasn't in school at that time. I was in another school which did not have class 12. So I remember people calling me during the exam and saying, see, there's a problem. I said, if there's a problem, there's a problem. There's nothing you can do. Then the next couple of years, and the last one, 2020 was it 2020? The last one also, there was error in the middle of the exam. They sent an email saying you can change the question paper and all that sort of thing, which I had already anticipated, and I told my principal that in the middle of the exam they will change it. Because with the list of equipments that they had given, there was no way to conduct that experiment. I was very certain of it. And it exactly happened like that. So I'm saying the council itself is making this mistake. How do you expect the teachers to get it right? Do you understand? Now, last year's and the year before, it was, the number of experiments given were reasonable. Yeah, that was reasonable.
Yeah.
But now, see, what's happening is, they have bloated that up for no reason, but you go ahead and use the single lens one. Nobody is putting a gun to your head and saying you have to use auxiliary convex lens or you have to compare EMFs and all that. Nobody's telling you that. You choose and you do the question paper as per, as it says in the instruction, in consultation with the teacher of the school. I mean, it's a very broad statement. When you say, Salman, if I were to come to your school, that I call you, talk to you and consult you and then prepare the question paper, I mean, I don't really know what that means, right? And well, I suppose it means, and which is what I did when I was there the last 2 years. That's what I did. I
last 2 years,
spoke to the teacher and consulted, and then we made the question paper. I was looking at what what you ask, what are the students comfortable with? Are they able to do this, that, and what you do? Why you going to make the job difficult for the children? No, you don't do that. So you keep it simple. What has the council done in the last 20 years? What are the questions that they have asked in the last 20 years? So I would stick to that. Now, the year in which the council is not conducting the exam, they are giving more options of conducting, more different types of experiment. It's just bizarre, in my opinion. Just completely bizarre. So stick to the basic experiments that the council has done all these years.
Okay.
Don't delve into any of those new ones.
Yeah, no, just as part of the syllabus copy, they have given, if you see at the end, the expected number of experiments which you have to finish by students.
Yeah.
They have given 11, in which the third one which I asked. Okay, so at least we should finish these 11, right? Minimum is this 11, right?
Yeah. So what does it say? Because I don't have the latest thing. Does it say that you are? See, when I was before the pandemic, it used to be 12 experiments.
Yeah. Now 11. Yeah.
So do you have to do all 11?
Yeah. So is it okay for you to share the edited one, the one which you had edited the
last one that I did? Yeah. Will you remind me in the group? I'll
yeah,
share.
Sure. I will text
That's
you.
okay. Yeah, sure.
And also another question. I really not understand. See, when we are using a meter bridge, the resistance of that wire should be like maximum 4 ohm, right? If I'm not wrong. But when my kids are doing, it's coming somewhere around 0.1 or 0.3. It's completely vary. And
wait. You're saying it's off by 0.1, or the answer is?
No, the answer is itself 0.3. That's what I'm saying.
Okay, so I think let me just take a second here and make a request to everybody who's here. I'd appreciate if you can turn on your videos. I would really like to see all of you, and I want to see the reaction that people have. Some of these things are so bizarre that it kind of, thank you so much. I'm very grateful. Thank you. So Salman, here's the question. Please understand this. When you buy a meter bridge, right? And I have tried with people from Ambala. I'm sitting down south here, and I was gone all the way to Ambala. I've got people from, and finally I kind of settled on one person in Chennai. There's a
you told me
company called Pico. But you see, when you buy a meter bridge, see the wire that comes with it, default wire that comes, you have to check that, right? Most probably because they give 2 ohms. So the question you need to ask is, this is why I said, as soon as you procure instruments, it is of utmost importance that you check them before you let them into the lab. Don't mix them with the rest of the things. Once you mix, there's no way of going back. It becomes very, very difficult, right? So for this, the bare minimum requirement as you must have a multimeter.
It's
so much so, in fact, recently when somebody called me regarding asking, this teacher is going to another school, and I asked this teacher, when you go to another school, take your multimeter with you. You understand? You know your multimeter. You know how the values you get there. Because when there's a problem there in the equipment, see, if you go with the sense that, okay, if there's a problem with my equipment, it's not my problem, they're not my students. They are students, right, of some school. So if you go there with the sense to want to help them, and if you I have opened up multimeters, this, that, I have done this just trial and error. I've made mistakes, which is why I want to share this with all of you to tell you where are the ways that you can get this correct. So now what you can do is take your multimeter, and multimeters, when you measure resistances, it has a big problem. You have to understand, this is the first thing you must understand about measuring resistance. What is our basic thing? When you're doing these experiments, our basic thing for optics is that you have the right lens. For electricity, the basic thing is that you have the wire with the correct ohms per meter, right? Which is said that it should be 4 ohm per meter. Plus, there is some error. This one is allowed. And the council has said, Constantine SWG. 28. SWG is standard wire gauge. You can check on Wikipedia what that means. It means that standard wire gauge means that SWG 28 means a certain diameter. Yeah, that's what it means. And the diameter list and the SWG ratings, like SWG 26, 28, 32, they have specific, what is the thicknesses. That is there on Wikipedia. You can check that up. Yeah. And it must be constant and wire. What I used to do is I used to procure the meter bridge, good ones. Then I will remove the wire that is already soldered in there. And I buy this constant and SWG 28, which is, by the way, very difficult to come by and very expensive, mind you. Yeah, they sell it by gram. 100 grams cost some, at least at that time when I got it, was 6,000 rupees. Yeah, but 100 grams is, I think you can refit maybe 50 meter bridges with it. Yeah, 50, 60, I don't know. I mean, there are quite a bit if you have to, I mean, I suppose you can find out what length you will get, maybe 100 meters you'll get. If you can procure one accurately and then leave it in the lab, you're set for life, right? But make sure it is 4 ohm per meter. When you measure resistances with a multimeter, yeah, when you measure, the problem is all multimeters are tuned to measure resistances above 50, 100 ohms. So when you're using your multimeter, any commercially available multimeter, even the best ones, the multimeter best ones that I know is best one hands down is a company called Fluke, F-L-U-K-E. If you see Amazon, you will see. In fact, I think I can just you can check up Amazon. There are many versions of it available. They're very expensive. You know, the cheapest one is 5,000 rupees. F-L-U-K-E, Fluke, it's called. There's another one called Rishab, R-I-S-H-A-B, which is also decent. And then maybe I should just share my screen and show you what I get. Hold on. Yeah. So this is this thing called Rishab. These are very good. Huh? These ones are very good. You can just take this down. The other one is called Fluke. These are expensive, but they're exceptionally good. Right. And you have to take care of it. Don't let anybody else use it and all that. Then it will last. You can see the price. Yeah, these are very expensive. The Rishabh one is, I think, is the best way. If you just take a regular multimeter, the one this is the one, this is the one I have at home. I keep one at home just in case. And I take this with me when I used to go, this is what Mastech. This gives you a fairly good enough thing. Okay. But if you have a full-fledged lab and all, I think you should go, at least you must have the Rishabh one. At least that is my opinion, right? Yeah. Let me. Yeah. This is the minimum. In my opinion, this is definitely be the minimum requirement. One of these, yeah, should be good enough, right? Now, in this, what is the problem? Measuring your 4 ohm per meter, or for that matter, even 10 ohm per meter with this multimeter is like measuring 3 volts with a 0 to 100 volt voltmeter. Do you understand? I'll say that again. Again. Measuring 4 ohms with any of these all these that you see there. Yeah. Measuring this 4 ohms or 5 ohms. Or what I do is, when you get these resistance boxes, no, they have 10 cells. 10. What I do is I stick this in and I take the reading of each dial position and I write it down and record it as soon as I get it. If I buy 10 of those with 0 to 10 ohms, they have 10 divisions. No, I stick this in and then I put it in a sheet, and then you can compare. You know which are the good ones, which are the bad ones. Yeah. My own personal experience has been, and this is very important, I have used 1, 2, 3, 4, 5 different multimeters, expensive ones, not so expensive ones. For almost all of them, when you measure the ranges of 0 to 10 ohms, the value that is shown in the ammeter is about 0.5 more than what it actually is, right? 0.4, 0.5 more. So if it is actually 4 ohms, it shows 4.4. Do you understand what I'm saying?
Yeah.
And that's the error, because you are measuring. It's like I said, it's like measuring, what do you say, the distance from here to my house with a matchstick. You put it here. Yeah. See, the error will be so large. Do you understand? It's like measuring, if you want to measure 3 volts, would you use a 0 to 5 volt voltmeter or 0 to 100 volt voltmeter? 0 to 5 volt. Yeah. So this, you don't have this. I did search, by the way, to measure low ohms very accurately. There is one available on Amazon. It's very expensive. It's about 10,000-15,000 rupees. It's not worth it, right? So the best way to come up was to just figure out a way in which you can, so over the years with the data that I had, I knew that all multimeters will give slightly off.
Okay.
Right? The best way, of course, is to try Wheaton's bridge. Use Wheaton's bridge, but Wheaton's bridge has a big problem. And this is I think I would urge one of you to remind me to talk about this Wheaton's bridge experiment. Yeah, I don't want to forget it. So remind me later on. Everybody thinks that's the easiest experiment, but trust me, that is in my opinion, it's the most difficult. I will tell you why, because the experiment itself has a problem. Yeah, I will explain that. In fact, I explained this in last year's video also. I delve into this. I will but somebody just remind me, just in case I forget. So this, you make sure that you test these. Once you test this, quickly check with it's a 4 ohm voltmeter, right? If you have a well-calibrated resistance box, put 4 ohms in that resistance box, connect these two, and then check, or put 2 in that, and check, make the Wheaton's bridge arrangement, and check if you're getting at 50 centimeters deflection. That cannot lie. Yeah, that experiment cannot lie. That is only, this is very important. Wheaton's bridge experiment, why is difficult is it brings in a lot of errors. Yeah, this has been and last year when I was talking about this, I think here in Chennai, Maya ma'am is there in PSBB. She told me, she's in the CBSE group. She came in the IC, she heard everything, and she told me, because in CBSE, see, they are very attuned. CBSE, their their syllabus and their practicals are exceptionally well researched, unlike the ISC. You understand? So there, they insist that the students, the balancing point that they choose resistance values such that balancing points are between 40 centimeters and 60 centimeters. Beyond that, it brings in a lot of error, lots and lots of error. Because if you do the experiment, you go tomorrow to the lab, set up your regular, I'll tell you this classic example, all of you try this. Go to the lab, set up your,
Wheaton bridge or meter bridge.
Like a student would do, right? Take your, that bobbin, 50 centimeter bobbin wound, and you put that there, use your, start with 1 ohm, up to 2 ohm, 3 ohm, 4 ohm, take up to 10, all readings. Take the balancing points and calculate the resistance. You will see that at 1 ohm, you'll get a value. 2 ohm, 1 ohm and 2 ohm, you kind of get about 4 ohm per meter, right? As you keep increasing from 2, 3, 4, 5, all the way to 10, the value you're supposed to get, in all readings, you're supposed to get 2, 2, 2, 1.9, 2.1 like that. But you will get 2, 1.9, 1.8, 1.6. It keeps reducing, it goes down all the way to 1.3. This happens, Mani sir and I was banging my head on the wall trying to figure this out. This happens because of terminal resistances on the terminals. Yeah, this was done. We employed a mathematical method, and I have the results for that. I think I should one of these days probably even write it up and share it with everybody. That I took all the values that I got and I drew graphs for them separately, and I saw that they all met, and I added, as a theoretical exercise, I added a terminal resistance as X, and then I ran the whole theory. And then when I plugged the values that I got into it, I found that for all values that I plugged in, I got the X values exactly the same, which clearly shows that there is a terminal resistance.
Yeah.
See, if the X values were different for each, then you know that I'm not doing my theory, I'm not doing it right. But all the X values, in fact, when I drew graphs, they all kind of more or less met at the same point, which very clearly indicated that there is a which is why they say stick to value. So if you have resistance boxes that gives you 1.5, 2, 2.5, those are more accurate, because then you can get between 1.5 to 2.5. In that itself, you have covered 3 readings, right? So you can keep it very close to the balancing point of 40 to 60. Then the experiment will work very well.
So you suggest that for meter bridge also, when we are doing, make sure that our balancing point is lying between 40 to 60.
Yeah, but it'll be difficult if you have 0, 1, 2, 3, 4, 5
Yeah.
values. It'll be very difficult. So what I used to do is I let them do the experiment. They will come and ask, and then I explain this to them, and I tell them not to worry about it. I mean, what else can you do? How will you get rid of terminal resistances? What, I'm going to buy new meter bridges I mean, I've got the best, those meter bridges that I have, those are probably really best, made of teak wood. I bought those 15 years back. Until date, there's no problem. So it was expensive when I bought it then, but till date, I have no problem. Whereas parallelly, before I joined, there was some made of, crushed wood and all that, MDF and all that. Those are all wrapped and it's at an angle. This one is pristine. After all these years, there's no problem. So good to invest in expensive equipment, because it's a one-time thing then if you take care of it. And it's teak wood, it can't fall down and break, so there's no problem. So I suggest that you check if you're getting, anytime you get vaccine, first thing you have to understand, this is the very basic philosophy of practicals, doing practicals. If you get an answer that is unexpected, right? I tell my students, rejoice and be happy, because you see, all great scientists, they didn't go to the lab thinking, I want the correct answer.
Yeah, that's true.
Yeah, they all went, they got wrong answers, they explored, and that's how they discovered new things. I'm not saying that our students are going to discover something out of the blue. But say, for instance, with this wrong answer, I was curious enough and I discovered something. And I actually put mathematics to it to prove it irrefutably that there is a problem, right? So what I'm trying to say is that when you prepare question papers, I would any day avoid, meter bridge. Unless you know the equipments in the lab that you're taking the question paper to, I would avoid it. Because it will unnecessarily stress the students for no fault of their own. It is supposed to be please understand, Wheaton's bridge is a brilliant idea. It's a brilliant idea because all you need is half a volt to run the experiment. You just need just a little bit of current is enough to run the experiment. That's how brilliant the thing is. But practically, because you have these circuits and they are, otherwise someone come up with a way to do the experiment where you don't have, these terminal resistances. Terminal resistances meaning these contacts that you have on the sides, those come up with some kind of resistances. And that's what it's all about. So try and avoid that, but not very easy. So let the experiment go when you're doing and putting it down in the lab journal. I always tell my students, you be very faithful and write truthfully. This is what you get. I will sign and give you marks for it. You understand? I will never lie. I would not let a child lie in the lab journal to get everybody get cute answers. If everyone gets 2 for all experiments, all 100 students, and then I come and see, that is absolutely unscientific, which means there is some, hanky-panky that went on. It's the way I see it, right? So I think there needs to be an overhaul of the way we look at how we do practicals. Yeah.
Okay, I will. So you would suggest to get a proper multimeter and check their resistance.
Please, multimeter is bare minimum. Yeah,
I have, but
if you don't have a multimeter in your lab, I'm very sorry, I can't help you with anything. There's nothing you can do, right? I would suggest, in fact, yesterday I spoke to this chap who used to deal my equipments. He's in Bangalore. So I spoke to him. So there is something called as the IC regulated power supply. I'll show you a photo of that. Let me share my screen. I was just getting ready just in case. Let me see. Yeah, this is the IC regulated power supply. Yeah,
I have used this in college.
Yeah, if you may have used this in college. I'm saying request your school to invest in one of these, right? This is 12 volt, 3 amperes. You will need a 12 volt or even 10 volt would do. If you have this and you see these 2 terminals, and you get these banana cables where you don't have to put it around and tighten it, you can just push it into the jack. All you need is 2 banana cables and this IC regulated power supply. You can calibrate all your voltmeters, ammeters, galvanometers, resistances. You can calibrate with this. I very strongly suggest that you invest in one of these. In fact, last year during these sessions, I called the dealer and I asked him what the cost is. He said it was 2,600 plus tax. I called him yesterday and I asked him the same thing, what the price. He said it is 5,400 per step. The cost is doubled. Yeah, you want to try and get this as quickly as possible. If your school doesn't mind investing in this, because you tell the school that this will help the students, and I can tell you how to calibrate this with this.
Yeah,
very simple, very simple. Take a 3-volt voltmeter.
Okay.
And then you put the positive in this and the negative. You can see my cursor, no? You can see.
Yeah.
So put the positive in this and negative in this. Okay. So this is the current knob.
Yeah.
Okay. Make sure, very important, calibrating voltmeters are very easy. Anytime you connect a ammeter where current is involved, you be very careful. You don't want to blow, because if you pass 12 volts through your 0 to 1 ampere, you'll blow it in no time. So make sure before you connect anything, you make sure this current knob is all the way down to 0. You connect this and slowly increase the voltage to 3 volt and keep this at exactly 3.00, right? Okay, keep this at 3.00, right? So you have 3.0 set. Now don't touch it. Don't touch it. You check your analog voltmeter. It should show 3.00. Okay, or if you want it to be a little better, because some may be a little this way, that way, you may want to set it as 2.80. You can do that. In this, you can get a, this is a fine adjustment knob. So once you get to about 2.75, then you can turn this slightly to get very fine adjustments, okay, to get very accurate. So if you get 2.80 here by turning these two knobs, this is the main knob, and this small one, this is a fine adjustment. So you get, like we have in the spectrometer, no? You move it with the hands and you have those fine adjustment things. Same way, this works exactly the same way, but make sure that this current is at 0, right? Then you connect this, 2.8, you connect your voltmeter. It should show about 2.8. You number that voltmeter, okay? Catalog them, number them. Now don't touch the this IC regulated power supply anymore. Take the voltmeter, you have written down what the value it shows when this IC regulated power supply shows 2.8, this shows say 2.75. Okay, remove it, keep it aside. Take the next voltmeter, put the 2 jags. What is the reading? Okay, write it down, remove it, keep it away. Take the next one, put it in. What's the reading? Like this you do for 10 or 15. And then you will see some voltmeters will show you 2.2. Then you know that you can't use that. Are you with me? Some will show you 3.5 or 3. Well beyond 3. Then you can't use that. Yeah. Of course, these voltmeters also, when you take them, make sure there is no 0 error. You adjust that carefully. There's a lot of small details that go into it, right? So once you get all that sorted out, check one by one. Ammeters, you want to do the same thing. Ammeters, you want to do the same thing, but be very careful. Voltmeter, keep the current at 0, plug this in. Yeah, and you want to set the ammeter value. See, why is this a voltage regulated power supply? Is because if you fix the value of voltage at 2.8, no matter what current passes through through the circuit, it will make sure that it always keeps it at 3 point. That voltage will be maintained. That's the whole point of this equipment, right? It doesn't allow this one to vary. On the other hand, if you set the current to say 0.890 ampere, right? And then if you jack up the voltage a lot, what happens is the voltage, once you have the full circuit, whatever you connect to it, the power supply will ensure that only 0.8 current passes through it, not more than that. So much so that it will drop the voltage. Even if you fiddle with the knob, it will drop the voltage such as to keep the ammeter reading at 0.8 or 0.9, whatever you choose. So similarly, you choose, put your ammeters, put it at 0.9, take one by one. That's why I said, if you have those banana cables, it's very simple. Take it, shove it in, write the value, pull it out, next, push it in. You can take 10, 20 voltmeters can be done in about 3 minutes. You can finish it. And then if you write it all down, and if all your voltmeters are numbered or ammeters are numbered, then you can see which number voltmeter is misbehaving and take it out of your pile. Don't use it. You can use the same thing for resistance also here. You keep the current value at, say, resistance box. How I used to do it is, I used to make sure that I have to remember how I used to do it. When I get it, it'll be very, so I would pass. I think I will fix the ammeter reading at about 0.8 ampere, right? This is where I remember I burnt one resistance box. So I learned it the hard way. So once I connect the resistance box and fix the ammeter value, I fix it, because resistance box, they all have a reading. You can't go beyond 1 ampere. The wire inside will just burn, or if it is the carbon resistor, it will just burn. Yeah, 12 volt and all, it can't stand. I'm sorry, large currents, it can't stand. It doesn't matter what the voltage is. The point is the current is what burns it. As long as the current is the current is done. So keep the current there, keep it at 1 volt. When you keep it at 1 volt, the ammeter reading and the voltmeter reading must be same, because V is equal to IR. Because R is equal to 1, V must be equal to I. You understand? Right? Then you change the knob to 2 ohms. So then you know that R is equal to V by I. The voltage value, for the same ammeter reading, you must get double the voltmeter value. Right? So then you put the knob at 3 ohms. Then you get 3 volt in the voltmeter and 1 ampere in the. So you keep doing like this, and you can calibrate all the knob settings of a single resistance box. Then take the next resistance box, do the same. And sometimes you find that for a particular resistance box, one value is not working, right? For whatever reason. So you, with a permanent marker, you mark on it and keep it aside. Or if even by chance you have to give it to a child, you tell the child, see, you got this value doesn't work, don't use it for the experiment, during the experiment, because they say, no, you can take any value between 0 and 10. They're not fixed on 1. Of course, you don't want to take that. This is the worst case scenario. Best case is that in any normal circumstances, you make sure that you don't give anything even with one single faulty reading. This will take time, but if you do it one time around in a year, or if you have a lab assistant whom you can show how these things are done, then they can keep it, the upkeep can be left to them and they'll do it well. Okay.
Yeah.
Yes. What else?
Last question. Okay.
Yeah.
If I will ask. Okay. Whenever we are measuring meter bridge, there will be actually wire will be on the scale, right? But actually, if you see, that wire is not exactly starting at 0, it has some length and ending.
Yeah.
Then how are we accounting that error?
Yeah. So that's enough, because when you make the wooden bobbin with the thing, no, with the 50 centimeter, you take a wooden thing and you wind the 50 centimeter wire around it.
Yeah.
So what I do is I don't take 50 centimeter, I take 52 centimeters, because 1 centimeter will go on going around on either of the ends.
Yeah. Okay.
No, it's not going and touching, right? I have to wind it under the terminal, correct? So I need to take an extra 1 centimeter on either side. So if you cut exactly 50 centimeter and then fix it, this is, I'm saying, wooden bobbin. I'll come to the meter bridge.
You're saying wooden. What are you referring? Wooden?
See, unknown resistance that you use, it's on a wooden piece or whatever you use. Yes. You will wind the wire and keep. It's called wooden bobbin, is how the council refer to it as a wooden bobbin, right? Okay. So this unknown resistance that you give, which is 50 centimeters or 60 centimeters of the same wire as it is in the yeah. So that when you cut, if you want 60 centimeters, because it has to be wound under the terminal, you want to use an extra centimeter or a centimeter and a half, so that you get enough space to hold on to it. Otherwise, it will come off. Then it's a problem. For a meter bridge, if it's a good meter bridge, you shouldn't have this problem. Okay. Terminals will be, first of all, the terminals will have 0 resistance. Yeah. Okay. And the point where the touching happens, it will be exactly at that 0 and 100 centimeter mark. Okay.
Then I think I will click a picture and I will show it to.
Yeah, please. I can tell you if there's a problem.
Yeah, I'll share it with you tomorrow.
Yeah, sure.
Okay then.
Yes. Anything else? Anybody else? I think people are getting bored. So I had put up some videos on my channel during pandemic, introducing for my students to introduce all the electrical equipments. Now something very interesting happened. Yeah. So there were 12 videos in total. So it's been 2 years now. Yeah. And I'm not a YouTuber or anything. I'd like to be one, but I'm not one. So these videos help the students, and I know that it helped a lot of other people, but something very, very interesting happened. If I now take it, it's been 2 years now. If you now take a look at the number of views of all these, I think one has some 4,000 views, only one. Another one has about 1,200 views. All the rest is 400, 500, 800, like that. Okay. But there's one video that has 20,000 views. One video, right? Can you guess what that video is? And that explains just about everything, my point about practicals. That one video is how to make measurement in voltmeter and this analog voltmeter and ammeter. Students don't know, if you're given a centimeter scale, you know how to find the measurement, right? But when I bend this like this at an angle, like an arch, and then put values there, they don't know how to make the measurement. How is that one video, which is rather longer, 20,000 views, where the others got only 200, 300, 400 views? And you should see the comments that people have written, oh, profusely thanking me. My point is, going back to basics is the way forward. Yeah, you have to go back to basics. Children don't know to take readings in voltmeter and ammeter. So, I would suggest that you go through those videos. If you don't, you can just message and ask in the group. I can share that with you. It's a playlist it's in my personal channel. Maybe I should have put it in this, but I wasn't thinking at that time. So anyway, so that is something that you can, it can be used as an introduction for teachers. Anybody can watch that. I talk about some finer details, only introducing. I'm not setting up any apparatus and doing experiments and all that, nothing. Each component, rheostat, the plug key, the resistance box, the voltmeter, the ammeter, then I don't remember the list, the jockey, how to use the jockey. Jockey was the last video. I even added some music to it in the background. I was just testing out my YouTube capabilities also. But anyway, that's joke aside. So yeah, so that is that. In the list of experiments that is given, my point is, very often people try and avoid using voltmeters and ammeters in setting a question paper, because then children only have to deal with galvanometer. But then in doing so, you have to inevitably use Wheaton's bridge, which has this problem, that it won't give you accurate readings. Actually speaking, if you know to take readings on voltmeter and ammeter, the easiest question that you can possibly give is that, let me share that. So this is 4 ohm, this is 1 ohm. So you have the total resistance you have R1 plus R2 is 5 ohm. And when you find the current I will be equal to your E divided by 5, which is, why don't you give 4 volt here? So you get 4 divided by 5, which is 0.8 ampere. Okay. Current will be this 0.8 ampere. Let the 0.8 ampere current pass through this. Now your experiment should be to connect this voltmeter, right? Connect the voltmeter. So what will be the voltage drop from here to here? What will be the voltage drop? If you touch this point, this jockey, if you touch at point B, what will be the voltage drop? I think I'll have to, hold on. Just give me a second. Let me just rearrange. That is, my question is, you have you have this 4 ohm per meter wire, right? And you have an EMF of, 4 volt. You have an EMF 4 volt, which is, this 4 volt is divided into 2 drops. One drop is across the 4 ohm per meter wire, and the other drop is across the 1 ohm in the resistance box. Okay, these are 2 drops in it. And so this voltage has to be dropped in the ratio for this, in the same ratio. So your I, we know, is 0.8 ampere. So let's say for here, the voltage drop will be IR, which is 0.8 into 4, which will be 3.2 volt. Okay, so then you can't use, you will have to, wait, this is the across V1. That is to say, let me erase this. This. The drop across, the drop across AB, that is the voltage across AB will be 3.2 volt. And this you cannot measure with this voltmeter. You cannot measure because you have a 0 to 3 volt is generally. And the potential drop across the resistance box, therefore, will be the rest of it, that is 0.8 volt. Okay. Now, then what you can do is keep the resistance value as 2. If you keep that as 2 ohm, don't keep it here. So then the total value you get is now 4/6 you get, because you have now R1 plus R2 is 4 plus 2, and you get 2/3 ampere. You can use this. If you have 2/3 ampere, now the voltage, the voltage AB will be equal to 2/3 multiplied by 4 ohms, which is going to be 8/3, which is how much you get. 8/3 is 2.67 volt. This can be measured with this, no problem. Yeah. So 2 ways of doing it is set up the question in such a manner that this is being used as 1 ohm, but ask the students to tap at the point where you get exactly 3 volt or maximum deflection or whatever, and then or start from here. 10 centimeter, what is the reading? 10 centimeter, 20, 30, what are the readings for this? So when you do this, you get a nice voltage versus length. You get these readings, and that's the experiment. This cannot go wrong, right? You're not changing the resistance box value. You're not calculating different current values or anything of that sort. You're only absolutely stuck to changing these length. And take this all the way to, it reaches the 3.2 will be here. So don't take that. It will stop at a little, say, ask them to take till 60 centimeters. So that should be well within the voltmeter. Once you have this, you can design an experiment accordingly with this. This is, in my opinion, this is the easiest experiment that you can do. The other, of course, way is that you make sure that this jockeys kept fixed at one place, and then you keep changing the resistance box values to get different values of V and A, and then you finally find V by I to get what the resistance values and so on. Yeah, that's another way of doing it. But this particular one will be a lot easier, very easy for them, provided they know how to take measurement in voltmeter and ammeter well. It shouldn't be a problem. Yeah, that's what I think. Yes, anything else? Actually, let me see what I wanted to tell. Yeah, I think that's just about it. I think I've covered everything I wanted to say, unless you have some question now, which I'll be more than happy to answer.
Sir, this is the last week, Karthik here. So the last week, my students have one practical sessions. So given a displacement method experiment, sir.
Okay.
Okay. So F is equal to 25S. So if the S is the slope is 0.4, then okay, 10 around 0.41, 0.42 is okay, 0.43 is okay, but 0.46, 0.47, 0.48 means that focal length will go to 11, 11.5, 12.
Yeah. So why is that? See, if you do the experiment accurately, you cannot get it wrong. Yeah. Just Karthik, I don't know if you've seen the video from last year, where I explained this displacement method and the theory behind it and all the problems that come along with it.
Okay.
If you just watch that once, I think it's in that second video, the advanced
Okay.
session I've called.
Okay.
There I explained this with the numbers, why it happens, why it has to be, we take 4f plus 10 must be the X value. All these things I explain very carefully. Yeah. You want to just go through that once.
Okay, sir.
I think that will really help. See, if you do the experiment accurately, there's no way that you can get the answer wrong, unless you make a mistake in plotting the points or even writing the values down, plotting the points. And there's another thing that could be going wrong here.
Okay, because
the fact that the student take the slope wrong. Do you understand? Sometimes the slope, the slight change of the slope, because when you choose your line of best fit, a slight change of the slope makes a huge difference in the value.
Okay.
That doesn't mean your focal length is wrong or your lens is bad. It's just that the experiment is designed in such a manner that slight changes of focal length, meaning, see, you change it by 1 degree or 2 degrees and it might change the S value so drastically that your answer goes up to 11 or 12. Then you have a problem, no? So in that case, if this is happening, my suggestion is ask them first of all to draw the line of best fit very light.
Okay.
Take 2 new points on that line. Don't take 2 already points. Take 2 new points on the line. Quickly calculate the slope and find the focal length. See what they are getting.
Okay.
Now, if it is 25S, which means when the S goes up, the F will also go up. they're directly proportional, right? Focal length is 25 times S. So if the slope is higher, the focal length will be higher. You have a value to get. I think you have to get 4. Huh? 4, then it will be accurate, is it not?
25 into 0.4.
Into 0.4, correct.
0.4.
You want to get 0.4. If you get, what happens if you get, so if the child knows that they have to get 0.4 for that, but they may not know that. So what you have to do is tell them, just draw it light. Yeah, you look at the final formula is all you have to see. If it is F is equal to some 25 times this one, then you know what the S value should be in order to get, because you see, let's admit, everybody knows going into this one, everybody knows what the value of the lens is. It's going to be 10 or 15. It can't be anything else, right? Yeah. Yes. So once they do distant object method, they immediately know if it is 10 or 15. So they know that's what's going to be the answer. So if they know what the focal length is, if you look at the formula, you know that if focal length is something, and you have to calculate something there in order to get the focal length. If it is in the numerator, they are directly proportional. So if the S has to, the slope has to increase, sometimes it is some 10 divided by S. If it comes, meaning if the slope increases, the focal length will decrease. So accordingly, you need to adjust the graph. Meaning sometimes even if when you draw a line of best fit, you may get an answer way off. Very often I've come across students who draw the line of best fit, looks fairly okay. But because they were off by 1 or 2 degrees in the angle, the answer went off very drastically because they didn't notice some small points, small things when they were plotting them. So they are allowed to adjust the slope slightly this way, that way, according to the situation. Yeah.
Okay.
If you know how to do this, you can communicate this to the students and tell them that, see, sometimes you get this, you draw a line. What they'll do, take the pen and draw a dark line. Then you have a problem. You have to get another graph and all that. Tell them what I use them is I tell them, don't hold here, hold at the end with the scale, and then just draw a light line. Take 2 points there. You don't even have to mark it there. Just quickly and just scribble and find out what the focal length is. I mean, slope is, calculate the focal length and see what you're getting. If you're getting a very high answer and if your formula is 25S, you know that your slope is too, you look at it. Can you adjust the slope a little bit to bring it down? But well within your, this I'm talking, everything else being okay. That is like,
X and Y,
X and Y values are all very well done. Then okay. Yeah, because when you, also this happens when you zoom it in. Zoom it in means when your scale is very large, a slight change in your line of best fit will throw your answer off big time. So they want to quickly just check, take 2 points, quickly calculate the slope and this. But I understand in the middle of the exam they may not be attuned to doing stuff like this. So, but you just have to give them enough practice. If it comes to that, they have no choice. They have to do this. Yeah. After all, you can tell them this is the easiest exam. All said and done, this will be the easiest exam they ever do in their life. The procedure is given, formula is given, table is given, circuit is given, everything is given. They just have to do it and report. No?
Okay.
Yeah.
Okay.
So yeah. Anything else?
Good afternoon. Actually, just wanted to ask, we have also received that list of practical from the council. So there are about 11 to 12 experiments. So I just wanted to ask that there's one experiment, last experiment, like best or electricity comparison of EMF of 2 cells. So is it there in the practical list, or do we have to do, because someone told me that it's been removed from the syllabus, so it's not there.
So, like I said, I haven't checked the latest syllabus because I don't work in an ISC school anymore. So I have not checked. Otherwise, I'm very careful. I go through this. It was removed last year during pandemic. They removed it.
Okay.
But I don't think such an, knowing the council, they may have, I don't think such a huge error will be there. This experiment of comparing EMF was there till the pandemic. It was definitely part of the, and I used to do it very, very carefully with the students, right?
Fine.
Now, my own advice is, don't give this for the exam. Why should you give it for the exam? The exam, you can give a simple experiment. Nobody has said that you have to give a very difficult. Are you going to another school?
I'm working in a school actually.
I know. My question is, are you going to another school to conduct the exam?
No.
So then you don't have to worry about it. Only thing is, whoever comes to your school to conduct the exam, but of course, if they give the thing, then it'll be, I hope they'll have to communicate what are the equipments that you have to keep ready and things like that. They have to communicate with you. So then if you think that this experiment's coming, it says in consultation with the teacher of the school. So you can consult and say that you don't want that experiment. I mean, it's their own words. No? I'm not, you look at the page number 3 is very clearly written that the visiting examination in consultation with the teacher of the school will produce the question paper. What does that mean?
Yeah.
So the general idea is that, you scratch your back, I'll scratch mine sort of thing,
Okay.
So, because it used to be this exchange business. I go to that school comes to,
Yeah.
that teacher in that school comes here. So that is the case. So the experiment is definitely there. Do you have difficulty with the experiment when the students do it?
No, as
Yes,
such.
sir, we had a difficulty, sir, when we were doing that experiment. We tried out during our practical classes. When we tried out with our Lagrange cell and Daniel cell, we didn't get it properly. Then we tried out with one dry cell and one Daniel cell. That also didn't work out properly with a 1 meter wire. Then we used a 10 meter potentiometer wire and we did that experiment.
Potentiometer, you got the answer?
Almost, not very accurately. Around 1.5, 1.6, we got the ratio.
Yeah, so
only between Lagrange and Daniel cell, we had problem with Daniel cell rather than with Lagrange cell. We had problem with Daniel cell. Lagrange cell was giving correct balancing length, but Daniel cell was not giving correct value.
So this Lagrange cell and Daniel cell, are you using the actual Lagrange cell Daniel cell or are you using an electronic substitute?
No, we are using actual Lagrange Daniel cell. We are preparing it, sir. Lab assistant is preparing that cell and we are using. And we measured it with voltmeter also. Once it
you're getting 1.08 and 1.5.
Yes. Not Daniel cell only is creating some problem. Lagrange cell
it's a very messy affair. My suggestion is that you get an electronic substitute. You get a Daniel cell substitute which gives you exactly that 1 volt. That it's big, this big, but it has only one job. Give you 1.08 volt. No other job it has. You keep that in the lab.
But when we tried with dry cell and one Daniel cell, we were not able to get the answer. Just showing same side deflection. We tried for almost
same side deflection. That's a different altogether. So there I can show you how that thing works. Just hold on, let me show you. This is the general, the circuit is this. So you are getting one side deflection. Actually, you must have a galvanometer also here. You are getting one side deflection basically because, see the drop, you understand between this point and this point, okay, this voltage AB. This voltage AB, this VAB must be greater than this voltage. Otherwise, this experiment will not work. And when it is, when this VAB is less than or equal, that is when you get a single side deflection. So, how do you increase this voltage? Now, voltage AB, how can you increase? There are 2 ways. One is increase this. The other is to decrease the value in the resistance box. Or a combination of both. If you are using a 1.5 volt here 2 volt will not suffice. You have to use 4 volt for sure. I'm quite certain of it. If you just take care of this, it will work. 100% it will work.
Okay, sir.
So make sure that the battery that you use gives you 4 volt. Just check. It will not have a problem.
Yes. That we are just checking every time when we are using, because we had the same problem with battery eliminator. We were using battery eliminator initially. So let
me give you another solution. When you have the circuit like this, right? And this is your A and this is your B. One quick method in which you can solve this is the ammeter resistance box. Okay. Instead of just take a voltmeter, connect this side and see what the voltage is. Very easy. Or use a multimeter quickly. See, the rest of the circuit with the cell and the jockey is there, and the galvanometer jockey, that's there. You don't worry about that. Don't connect the jockey. Without connecting the jockey, when you're not getting it right, without connecting the jockey, take a multimeter and measure this voltage. If this measure voltage is greater than the voltage of this guy, it must work. It must give you opposite deflection. There's no other way. That is the way nature works. It cannot go wrong.
Yes.
So this is what. So this is like when you are in the middle of the you're in the middle of the experiment. in the lab session is on the way and they say only one side. Take your multimeter, just quickly check if the voltage, 100% that voltage will be lower than 1.5 volt. That's why you're not getting it. So then you have to, the main battery voltage has to go. Children, very often they also get these knobs and all. I always keep the knobs at 2 volt and give. I tell them very clearly, read the question. It will say 4 volt means you have to change the knob. They think that sir has to do everything for you.
They'll keep in 6 volt and they'll do
yes,
the experiment.
So these are
they have seen 6 volt, 8 volt they are keeping.
6 volt is crazy. 4 volt is more than that. You don't need more than that.
They are just turning it, and now after this pandemic, children are very crazy. They are just keeping it in 6 volt. They want to find out what will happen. Their first question will be, will it burn, ma'am? Will it burn? Will it burn off? That is their first question. And they want to try that. They are very curious to try that. Rather than doing the experiment, they are trying with 6 and 8.
Okay.
Fine, sir.
So you can do this quickly. This is maybe for all experiments, it will be good to come up with small ways in which, and that's why I said multimeter is very handy in a situation. You can quickly go pinpoint between 2 things and figure out what's going on. So you can't do that with anything else, no? So okay, I think we've grown pretty thin. So I think we'll call it a day. Anything else if you have, you can ask. Otherwise, please feel free to call me and we can take this forward. Okay. Okay, thank you very much for joining.
Thank you,
Thank you, sir.
Yeah.
Thank you, sir.
Bye.